Okay, I want to take a look at this midterm exam and go through all the solutions. If you have any questions, contact me through WellMap, either on discussion or send me a WellMap message. But just quickly, there's 18 questions. Each of them was counted as 5 points apiece, which adds up to 90, plus 10 points for your name. So here we go. Find the limit as x goes to 4 of this thing. Well, if you plug the x equals 4 in, it turns out you get 0 divided by 0, which means you got more work to do. But it also tells you that x minus 4 is a factor. So x minus 4 is a factor of the top and the bottom. The other factors are x plus 6 and x plus 4. The x minus 4s cancel out. Once you've canceled out that 0 over 0, now plug the 4 back in. You get 4 plus 6 on the top, 10. You get 4 plus 4 on the bottom, 8. 10 divided by 8 is the same as 5 divided by 4. You could leave it like that, or some people wrote it as 1.25. Whatever. Either one's fine. Likewise, number 2, if you plug the 1 in, this is the limit as x goes to 1. You're going to have 1 minus 1 on the top. You got 1 minus 1 on the bottom. You got 0 over 0. It means you got more work to do. There might be a limit still. Personally, I did this one by factoring the x minus 1 into square root of x plus 1 times square root of x minus 1, and then the square root of x minus 1's cancel out, leaving me a 1 on the top and a square root of x plus 1 on the bottom. Plug the x equals 1 in. You got square root of 1 plus 1. That would be 1 plus 1 is 2 on the bottom, and you got a 1 on the top anyway. 1/2 is the answer. There we go. Number 3. This is a limit as x goes to infinity. Well, as x goes to infinity, these are polynomials top and bottom, so it's the biggest power that really matters. You can cancel out everything else. You got a 3x squared over x squared. That's 3. Like I said, I'm going to go fast. You can ask for clarifying questions on the discussions. Definitions. It shouldn't be a surprise that the definitions were on this test. What's the limit? Definition of limit? Well, L is the limit of f of x as x approaches a. If for each epsilon bigger than 0, there exists a delta such that if 0 is less than the absolute value of x minus a is less than delta, then f of x minus L in absolute values is less than epsilon. I also accepted the way the book has it, and with the whenever statement, they say this whenever that. It's okay. Definition of continuous, really all you need. It's continuous at a if the limit as x goes to a of f of x is f of a. People included the 3 things. That means this exists and that exists and they're equal to each other. But just saying that they're equal to each other is enough for the definition. And what's the definition of the derivative? Given a function f of x, the derivative is another function, which we call f prime of x, and it is the limit as h goes to 0 of f of x plus h minus f of x all over h. F of x plus h minus f of x all over h, provided, of course, that this limit exists. Number 7, use the intermediate value theorem to show that the function has an x-intercept between x equals 0 and x equals 2. The fundamental theorem of calculus is, where'd that come from? The intermediate value theorem is a theorem about continuous functions. It says if your function is continuous and you've got a closed interval, then the function has to hit every y value between the y value at the starting point and the y value at the ending point. This is a polynomial. It is a continuous function. You had to say that, because if you don't mention that the function is continuous, then you don't really know that the intermediate value theorem is applying, right? Because for non-continuous functions, you might have a break in the graph where you're coming up and then all of a sudden it jumps up here and it misses all the y values in between. So you got to have a continuous function. This is a continuous function. The y value at the start is -1. The y value at the end is 9. Continuous function that starts at -1 and goes to 9 has got to go through 0 somewhere. This is less than 0. That's bigger than 0. So I got to hit it somewhere. Right? So you got to say that it's continuous, and the intermediate value theorem gets you that it's equal to 0 somewhere. Use the definition to find the derivative of this function at 2. If you did not use the definition, you did not get credit for this. I want to see that you can do all the different things within what we've learned this quarter. And one of them was using the definition of derivative to calculate derivatives. Now, actually, you had 2 options here because there were 2 definitions that were given. You could have done the x minus a thing. So x is going to, you could do the limit as x goes to 2. of f of x minus f of 2 all over x minus 2. That was acceptable. Or you could use the other definition of limit, which is the x plus h minus f of x all over h, where x is being replaced by 2 here. So I chose to do it this way, but I also accept it if people did it the other way. So plugging into the function here, f of 2 plus h, so in a 2 plus h is going in for the x there, so square root of 3 times the quantity 2 plus h minus the square root of 3 times 2 all over h. I'm then going to multiply by 1, so I'm going to multiply top and bottom by the conjugate of that numerator. So put a plus sign in between there. When you FOIL the top out, the same thing with square root, so the square root just goes away. The outsides and the insides are the same thing, except that one's got a plus sign and one's got a minus sign, so they cancel out. And then you've got a minus square root of 6 times a plus square root of 6, which is minus 6. So that's the numerator. The denominator, I just write the two factors down. Multiplying this through, you got 3 times 2 is 6. That's going to cancel out with that 6, but then the 3 times h is a 3h there. So the h now cancels out. That's the 0 over 0 canceling out. So now you can plug the h in. You got a 3 on the top. You got a 3 times 2 under the square root there, and you got another square root of 6 there. So square root of 6 plus the square root of 6 is 2 times the square root of 6. So either you could leave it like that or simplify it a little bit like this. Okay, you had to use the definition, one of the definitions or the other. Number 9, similarly, I want to see you use the definition. This one I didn't do it at a particular point. I just said give me it as a function. So I'm looking for the limit as h goes to 0 of f of x plus h minus f of x all over h, right? The f of x plus h here, you got an x plus h plugged in for that x. So 1 over 2 times the quantity x plus h. This one I'm going to simplify by, again, multiplying by 1. But I'm going to look at all these denominators. So I got a common denominator of 2x plus h times x. So multiply top and bottom by all of those things. When I use a distributive property, I'm going to multiply it here, and I'm going to multiply it there. This first fraction is going to cancel out the 2 and the x plus h, leaving just the x. That's right here. This times the second fraction, I've got the 2 canceling out and the x canceling out, but leaving just the x plus h. But there's a minus sign in between. So there's the minus sign and the x plus h. And in the bottom, I just write them all out. I didn't distribute anything. I just wrote them down. Each factor is still there. Now, when you distribute the minus sign through, the x and the minus x are going to go away, but you're going to end up with a minus h on the top. So the minus h and the h cancel out, leaving just a minus 1 on the top. Now that you've canceled out the 0 over 0, plug the h back in. You got a minus 1 on the top, you got an x plus 0, and a 2x. So the denominator looks like 2x squared. So minus 1 over 2x squared. If you did not use the definition, I did not give you credit. You gotta do what you're asked, because I'm trying to test all of these things. You have plenty of chances on the subsequent problems to show me you can do the shortcut rules. This is where I want to see you do the derivative by the definition. All right, here we go. Graphical derivatives. So here's a graph. I want you to draw the graph of the derivative. Okay. Now, I accepted a lot of different things over here. I tried to draw a parabola so that the derivative of a parabola should be a straight line. But if you thought this looked more like a sine curve, then you might have drawn something that looks more like a cosine curve over here. As long as I could see that you realize that it started with a positive slope, so you're starting up here positive somewhere, and the slope is getting less as you go, so this is dropping down, and there's a spot here where the slope is 0, so that's where you hit 0, and then you've got negative slopes for a while, getting more and more negative. So whether you do that as a straight line or whether you do it more like a, like a sine curve or cosine curve, sorry, more like a cosine curve, I didn't care as long as it was high, 0, low, right? Positive, 0, negative. That's positive slope, 0 slope, negative slopes. That's what I want to see on that side. Then you have a sharp corner. It's not a very sharp corner, but it's sharp enough that suddenly I had a slope of like -3 here, or -5 or something, and then suddenly the slope is -1. So there's a break, open circle, and then it's a slope of -1, straight line through there. Then there's another sharp corner, which suddenly you get a slope of 0. So right through here is all slope 0. And then a third sharp corner, which suddenly jumps to a slope of 2. So up here, 2. Okay. I didn't want to see these connected things because there's breaks in the graph. There's a discontinuity. There's a sharp corner. There's not a discontinuity in the graph. There's a discontinuity in the derivative at those sharp corners. The slope suddenly jumps from one to another. And so you put an open circle and don't connect them. Number 11. This is just take the derivative. Use the shortcut rules if you want. 3x squared minus 10x. The biggest issue people had here was with the cubed root of x. That's x to the 1/3 power. So it would be 1/3 x to the subtract 1, so negative 2/3 power. And then the derivative of 8 is 0. So just the interpretation that people had of what does the cubed root mean? They had different incorrect exponents, but this is the way it should be done. 12. Quotient rule. Bottom squared, bottom times derivative of the top minus top times derivative of the bottom. Any algebra you do after that is just bonus, but I wanted to see that you could get that quotient rule. And the derivative of e to the x is being e to the x. This one was a little tricky for people because of misunderstanding of the notation. Sine to the minus 1 of x does not mean 1 over sine x. Right? 1 over sine x is the cosecant. I would write it this way. This notation, when you're using it as with a function, means the inverse function. So the inverse sine, or we call it sometimes the arc sine. And the derivative of the arc sine is 1 over the square root of 1 minus x squared. Okay. So there's a chain rule going on here because I don't have just the arc sine of x, I have the arc sine of 2x. So instead of the x squared, I've got the 2x quantity squared, which turns out to be a 4x squared. But because this is not just an x, there's a chain rule that pops in as well and says, hey, you've got to multiply by the derivative of the inside. But the derivative of the inside is 2. So hence that 2 in the numerator. Okay. I did have some people do this really nicely, not remembering how to do the derivative of arc sine. They just took the sine of both sides and just implicitly differentiated very nicely. It was good to see people actually do that. Without remembering this, they could still figure out how to do it. I am going to stop this video right here and start at the next one. I'm running short on time.